Hello students, I am Kirti from Computer Science Department, gsipucmysuru College, Mysuru. In the previous session, we have studied about stack. So what is a stack? A stack is an ordered collection of items where insertion and deletion of elements takes place at the same end. So a stack is a collection of elements where insertion and deletion of elements takes place at the same end called stack. So here I am inserting an element called 40, that is the insertion operation is called as pushing an element, while removing the same element at the same end is called as popping of element. Popping of element at the same end called top. Same end called top. So what are the operations we can perform on stack? In stack we can perform stack operation, that is to create an empty stack. To create an empty stack we are using stack function, and push function is used to push an item into the stack, and pop function is used to remove an item from the stack, and isEmpty function is used to check whether a stack is empty, and size function is used to return the maximum elements of the stack. So these are all the operations what we can perform on stack. When it comes to the representation of stack, there are of two types. The first one is array representation of stack. So in array representation of stack, the size of the array is fixed. So here we are storing the items of stack in an array. See, the stack contains 10, 20, 30 and 40 as its items. So we are representing the stack in terms of an array. So the array grows in this direction. But in today's session, we are studying about the linked list representation of stack. Linked list representation of stack. Why we need to represent stack in this linked list data structure? Because sometimes in a program the stack may be required to increase its size to store the items, that is during the execution of the program, that is in the form of dynamic creation. But it is not possible to increase the size of a stack during execution. Dynamic creation of a stack is not possible when we are representing a stack using arrays. So in this case we require linked list representation of stack. In linked list representation we can insert an element by creating another node. Now let's see what is a linked list. A linked list is a linear collection of data elements called nodes. So each node consists of two parts. A linked list is a linear collection of data elements called node. So each node consists of two parts, that is data part as well as the link part. Data part and link part. So this data part contains the information of the data as well as the link part contains the address of the next item. So this data part contains the information and the link part contains the address of the next node in the list. So how to create a linked list? So in the linked list, it contains a pointer start gives the location of the first node, So in the first node, it contains information, that is, it contains the information of the data. For example, it contains 10 and it contains the address of the next node. In the next node, the first part contains the information and the second part contains the address of the next node. But in the last node, in the second part, it does not contain the address of the next node, but it contains null, which represents the end of the linked list. It is not connecting to the next node. So this linked list contains 3 nodes. So in the first node, it contains an element called 30. In the second node, it contains an item called 20. In the third node, it contains an item called 30. So this is about linked list. So what is linked list and how to create a linked list? Now let's see how to insert an element into the linked list. So insertion operation. So what is insertion operation? Insertion operation refers to inserting an element into the node. So how to insert an element? So by creating, I want to insert an element at the end of this node. So how to insert? By creating a new node, I am going to insert an element called 40. So how to create? First, I have to create a link for the next node. So in the next node, I am going to insert an element called 40 and in the link field, I am going to write it as null. That is the end of the linked list. So this is about insertion operation. When it comes to deletion operation, so if I want to delete an item called 30, so how to delete? In stack, it is not possible to delete the middle item in the stack. So while deleting an item 30 from the stack, first I have to pop out an element 40, then I have to pop out an element called 30 from the stack. But in linked list, I can directly delete this item by providing the link of the last node to the previous node. By providing the link of last node to the previous node. See, I am deleting this. I am deleting this element from the node. So I am providing the link of the next node to the previous node. So this is how we are performing insertion and deletion operation in linked list. So this is why we require linked list representation of stack. As I told earlier, in array representation of stack, it is not possible to increase the size of the stack, as the size of an array is fixed. To store the items of the stack, we cannot increase the size of the stack during runtime. But in linked list representation, we can increase the size of the stack during runtime. That's why we require linked list representation of stack. Now let's see how to push an item into the stack as well as popping off element from the stack. Algorithm for push operation. So, how to perform push operation? While pushing an item into the stack, first we will check whether it is in underflow or in overflow state. If it is in overflow state, we cannot insert an item into the stack. So, what is an overflow state? Overflow state means if the stack is full, in that case, we are considering it as overflow state. If the stack is completely empty, then it is in underflow state. So, while pushing an item, we are checking for overflow state. That is, if top is equal to n minus 1. That is, if the stack contains 10, 20, 30 and 40. So, this is n minus 1 position. So, if top is, so this is the top of the stack, right? If the top is n minus 1, then it is in overflow state. So, in this condition, we cannot insert an item into the stack, right? So, what is the first step? So, in this condition, so stack, so here stack is the array that contains n elements and top is the pointer of the top element of the array, an item is the element to be inserted into the stack. So, these are the prerequisites we should know in advance. So, what is the first step? First step, we have to check for the overflow state. So, what is the condition? If top is equal to, n minus 1, then print stack is overflow. If the stack is overflow, we cannot insert an element into the stack. So, exit end of F. So if the stack is not in overflow state, then we can insert an element into the stack by incrementing the top. We can insert an element into the stack if the stack is not in overflow state. We have to increment the top. So that is top is equal to top plus 1. That is increment the top. See here. If the top is minus 1, that is in underflow state, then we can insert an item into the stack by incrementing the top. So now the top becomes 0. The top becomes 0. So what is the next step? We are inserting an item. So item called 10 at the top of the stack. So that is, we are inserting an item to the top of the stack. Top of the stack. So after inserting an item into the stack, we are returning. So this is an algorithm for push operation. So while performing push operation, what we have to do? First we have to check for overflow condition. If top is equal to n minus 1, that is if the stack is full, we cannot insert an item into the stack. So in that case we are exiting. If this condition is false, then we can insert an item into the stack by incrementing the top. So we are inserting an item to the top of the stack and we are returning from the stack. Next, let's see how to perform pop operation. Algorithm for pop operation. Top, size and item. So here stack is the array which contains n items and top is the pointer to the top of the stack item is the element to be removed. So what is pop? It is nothing but removing an item from the stack. So it is also called as popping an element from the stack. So now let's see how to perform pop operation. So consider an array which contains 10, 20, 30 and 40 as its items. So the top of this stack is position 3. So now I want to remove the elements from the stack. So first I have to check whether the stack is in underflow state or not. What is the meaning of underflow state? So if the stack is empty, I cannot remove any item from the stack, right? That state is called as underflow state. So if the stack is in underflow state, we cannot remove an item from the stack. What is the condition? If the top is equal to -1, then we cannot remove any item from the stack. So here the condition is false. The top of the stack is 3. So we can remove an item from the stack. So how to remove? So first we have to remove 40 from the stack. That is, so in the first step we are popping out an element called 40 from the stack. Now the stack contains only 10, 20 and 30 as its items. In the next step, I am going to pop out an item called 30. So insertion and deletion takes place at the same end called top. So now the stack contains 10 and 20. So the top of the stack is now 1. So again we are removing an item called 20 from the stack. So now the stack contains only an item 10. The top of the stack is now 0. So now I am removing an item called 10. So now the stack is empty. So the position of the top is -1. So this is how we are performing pop operation on stack. So if the condition of top is -1, we cannot remove any item from the stack. So the first step is step 1. If top is equal to -1, then we have to print it as stack is underflow. We cannot remove any item if this condition is false, then we can remove any item from the stack. So what we have to do? We have to remove an item from the stack, that is from the top of the stack. We are removing the top element of the stack. Top element of the stack is removed. Top element of the stack. So after removing an item from the stack, top gets decrement. See here, in this case the top of the stack is 3. After removing an item called 40 from the stack, the top gets decrement. That is, in this case the top is equal to 2. Top gets decrement. So top is equal to top minus 1. So after removing all the items from the stack, we are returning from the stack. So this is how we are performing pop operation. So what is a stack? A stack is an ordered collection of data items where insertion and deletion takes place at the same end called top. When it comes to push and pop operation, in push operation first we have to check for overflow state. If top is equal to n minus 1, we cannot insert any item to the stack. So if the stack is not in overflow state, we can add the elements into the stack by incrementing the top. While in pop operation, first we have to check for underflow state of the stack. So if the stack is in underflow state, we cannot remove any items from the stack. As the stack is empty, we cannot remove any item from the stack. So if it is not in underflow state, we can remove an item from the top of the stack. So after removing an item from the stack, top gets decrement. So this is how we are performing insertion and deletion of an item from the stack. So this is about in this session. Thank you.